Welcome back. I think there is no better quote to define descriptive statistics that, together with my previous examples, can capture the strengths and weaknesses of this statistical tool, especially coming from a renowned expert like Charles Whelan that spends a lot of effort to educate on the proper use of statistics and the danger of misusing such tool and using deceptive statistics instead of descriptive statistics. But this gives me a good platform to introduce descriptive statistics and the tool set that we can use to summarize any data in a manageable and meaningful way. Think about statistics as a way of communicating insight in a very accessible way. So, where do we start? Well, we start by showing you that you already know statistics, you already know descriptive statistics, and use it every day. Let me go back to one of the questions I asked you earlier. How long does it take to go to your office or school? What happens to your thought process when I ask you this question? Well, probably you're recalling how long did it take to go to the office or school, let's say last week, and your answer will be something like, on average it takes 25 minutes. Congratulations! You just apply a basic concept of descriptive statistics, called the measure of central tendency. But before diving into specifics, let me introduce a core concept in statistics: random variables. I ended the previous video with a very strong statement. Describing the data is knowing the data. I want to go even further and ask you, what is the data tried to describe? Well, let's go back to that question. How long does it take to go to your office or school? You can answer this question very methodically. For the next year, take note of the time needed to get to your office or school. You don't need to do this every single day, but let's say take 10 measurements a month by going to the office and back from the office. Take notes. I ask you to do this for an entire year, so the data will reflect seasonal changes and the type of commute both to and from the office. In this way, the data will reflect traffic patterns at different times of the day. What we are doing is taking measurements of the reality we are interested in, the commuting reality. Here is a snapshot of the data collected during the year with the various commuting times. Congratulations! You just created a random variables of your commute. Random variables in statistics are not the traditional variables introduced in a computer science or algebra class. In statistics, random variables are denoted with a capital letter like X, Y, and so on. They are used to represent random processes, in this case the commuting time, and generate numbers like probabilities. I will not go into the details of random variables, but there are a few points I want to make that relates to machine learning. External phenomena are too hard to measure. In our example, we will need to take a precise commuting time every day for 365 days. Not impossible, but definitely annoying. Taking measurements of the length of all the red snappers in the world will be impossible. So, instead of interacting directly with the world out there, we take a set of measurements, our sample, of the phenomena we want to describe. We try to generate as much quality data as possible. By doing this, we are creating a random variable with the goal of using it to describe the reality we are interested in place of the actual reality. We then use this random variable as a proxy to understand our commuting phenomena. Instead of measuring reality, we create statistics using this random variable in place of the reality. Instead of changing reality by changing some parameters, we can use the random variables to measure the results of that change via a simulation. For example, with a random variable, I can ask the question, what would be my commuting time if I leave home, this is the parameter, at 8 o'clock in the morning instead of 9? Instead of measuring this change by leaving your home at 8 a.m. for 1 year and at 9 a.m. for another year, we can simply use the random variable we created and measure the effects. For example, calculating the mean of commuting times when leaving at 8 o'clock in the morning and comparing it with the mean of commuting times when leaving at 9. Given the data we collected contains commuting times at both hours. We will also see that the values of a random variable will follow a certain shape that we will call distribution, which will allow us to measure probabilities and do other interesting things. Okay, with this concept in place, we can start asking questions using the random variable instead of going out there and commute.